All right, so piggybacking on to the previous lesson, we reviewed all the different functions that we did in multiplication, addition, subtraction, division of fractions. But this one's going to take it a step further, and then the next two go a little deeper. So we're going to be dividing with whole numbers and mixed numbers. When we go through these processes, once again, and yes, I say it every video, it's important. Make sure you're following along, you're paying attention, your brain's engaged, so you're actually listening to what we're doing, and that means your pencil's going to be in hand, and you're going to be doing everything that I show you so you know exactly what it is we're supposed to do. So we start with this situation. Now I'm going to explain story problems a little bit more when we get in lesson 10, because that's what lesson 10 is all about, is story problems and breaking them down. But the whole key to a story problem is knowing the amount that we're actually starting with and then what we're supposed to break it into. This says a science teacher has 1 2/3 cups of baking soda. That's what they have, so I know that that's going to be the amount that goes first. Then it says she performs an experiment for her students by mixing 1/6 cup of baking soda with vinegar. If the teacher uses the same amount of baking soda for each experiment, so I know it's dividing because it's going into equal groups, that's why they use each, how many times can she perform the experiment? So I have to know that 1 2/3 is going to be my starting number. It's going to be out front. And then it's going to be divided into how many equal little groups. That's going to be my second number. Once I got that then I know I'm doing division and I have to have a fraction, right? So reviewing what we talked about, I mentioned in the previous video, but we didn't have to do it. It is on the bottom front side of that paper that I told you to have anytime we're doing fraction work. So I know I have 1 2/3. I'm going to start at the bottom. I'm going to multiply. So it's 3 times 1. That gives me 3. And then I add that numerator. So 3 plus 2 is going to give me my new numerator, which is going to be 5. My denominator always stays the same. So 1 2/3 is the same as working with 5/3, and that's the only type of number I can use in multiplication and division. Has to be a fraction, even though it's an improper fraction or it's top heavy. So I'm going to take my 5/3, and then I know, since it's going into each equal groups, because it says in each time, then I know I'm going to be dividing by 1/6. Now I go back to the same steps that we reviewed in the previous lesson and we did in the lesson before. I know I cannot divide fractions, so I know I'm going to have to keep my first fraction. Then I'm going to change my division to multiplication, and then we do that reciprocal thing, right? I flip my second fraction. That gives me multiplication, which is much easier to do. So I know I'm going to keep my 5/3. I know I'm going to change division into multiplication, and then I'm going to flip 1/6 into 6/1. And any time that I have multiplication, I see if I can cross reduce, because that makes my work a little bit easier. I can see that 3 does go into 6 evenly, so reducing means, once again, dividing numerator and denominator by the exact same number, and in this case, we're going to use 3's. 3 goes into 3 one time, and 3 goes into 6 2 times. So now I'm left with multiplying straight across. That gives me 5 times 2, which is 10, and 1 times 1, which is 1. So I end up with 10/1, and anytime I have 10/1, I'm going to keep that whole number and drop the 1 off. So I know I have 10, but I had a story problem, right? 10 what? So I know I have 10 times that I can do that experiment, because the question says, how many times can she perform the experiment? All right, so our practice problems, it's going to be the same math every single time, getting rid of that whole number or that mixed number so that I can change and go through my steps to multiplication. I'm starting with 3 1/3 here, so it's always going to be the same steps. I start at the bottom, which is my denominator, and I multiply. 3 times 3 gives me 9. Then I add. 9 plus 1 is going to give me 10, and then I keep my original denominator. So I have 10/3 that I'm going to plug into where that 3 1/3 starting out. So instead of 10/3, I'm going to, or once I have 10/3, I'm going to keep it and I'm going to drop it down. Division becomes multiplication, and then I find that reciprocal, I flip the second fraction. So I have 1/3, and it simply becomes 3/1. Now I look to see if I can cross reduce. Well, I have 10 and a 1, and a 1 is the lowest I can go. So those can't be cross reduced, but I've got the same number the other diagonal, don't I? A 3 and a 3. So those automatically cancel out. Those automatically become 1s, and it makes my math a lot easier. Now I'm multiplying across. I have 10 times 1, which is 10, and 1 times 1, which is 1. And once again, if 1's in my denominator, I just write it as a whole number of 10. On number 2, I have 2 and 1/2, which I know I can't use, so I have to change that into an improper fraction. So I start at the bottom. I'm going to multiply and then add. So I have 2 times 2, which is going to give me 4. And then I'm going to add that 4 to my numerator. 4 plus 1 gives me my new numerator of 5. I keep my original denominator of 2. So now I know that 2 and 1/2 is the same as working with 5 halves. Once I have 5 halves, then I know that's what I'm going to keep in my first position. Second step, division becomes multiplication. Third step, with that 1/6, find the reciprocal, flip the second fraction. So I'm going to work with 6 over 1. 5 and 1 can't be cross-reduced. 1's as low as I can go. However, 2 does go into 6 evenly, so I can cross-reduce with 2's. 2 will go into 2 evenly 1 time, and 2 will go into 6 evenly 3 times. Then I'm left with multiplying across. Numerator to numerator, denominator to denominator. I get 5 times 3, which is 15, and 1 times 1, which is 1. And then, since it's over 1, I just keep my numerator as a whole number of 15. On number 3, I have 2 and 2/3. Well, here I had 3 and 1/3, and here I had 2 and 1/2. I haven't switched that one over yet, have I? So I can't just look for somewhere else. I actually have to show my work on how to change those over. It's not difficult work, but some of you just want to say, well, I did it in my head, and doing it in my head does not get me credit for showing my work. So I know I'm going to have to take 2 and 2/3. I'm going to start at the bottom, multiply. 3 times 2 is 6, and then I'm going to add. So my 6 plus my 2 gives me my new numerator. 6 plus 2 is 8, and I keep my denominator of 3, and I know that that goes in place of the 2 and 2/3. So I'm going to keep that one in the right position. I'm going to change division into multiplication, and then I'm going to flip my second fraction. 1/6 becomes 6 over 1, and I see if I can cross reduce. 8 and 1, I can't cross reduce those, but I've got 3 and 6. 3 will go into both of them. So 3 will go into 3 1 time, and 3 will go into 6 2 times, which leaves me with multiplying fractions. So I multiply across. I will have 8 times 2, which is 16, and 1 times 1, which is just 1. Once again, I keep my numerator, since it's over 1, as a whole number. Should be pretty easy, right? If I'm going too fast, remember you can pause the video and rewind as many times as you want, at home, at school, wherever you're working. Number 4 then, I have 3 and 1/2, which I can't use, so I have to change it as well. So I'm going to start at the bottom, and I'm going to multiply. 2 times 3 gives me 6. Then I'm going to add to my numerator, 6 plus 1. Then I get my new numerator of 7. I keep my original denominator of 2, so now I'm working with 7 halves. It's in the first position, so I know I'm going to bring that down. Then I change division to multiplication, right? And then I flip second fraction. So instead of 1/2, I have 2 over 1. Notice I have 2's that are diagonal one to another. Those cancel out and they both become 1's. Now I'm left with 7 times 1 and 1 times 1, which gives me 7 over 1 as an answer. And therefore I know my numerator is just a whole number of 7. This should be a pretty easy lesson. That's what I'm hoping for. Tomorrow is a little bit more difficult because we're going to be changing both of these in tomorrow's lesson. So if you have any questions, then please come and ask. If you don't, then you have assignment 117, page 117, 2 through 6, fewer questions now, and page 118, 1 through 6. Come and ask if you don't quite get it, and if not, you should have plenty of time with this being a 10-minute video to get all of your homework done.